Hey guys, welcome back to General Chemistry. Today we're going to take a turn into something called enthalpy. So that's a big kind of crazy scientific word. So what we're going to do with this lecture is we're just going to break down what is enthalpy and what it means to us as chemists. So since thermochemistry is a science that deals with the relationships between heat, work, and other forms of energy, it's a branch of the thermodynamics. We talked about that. And then specifically as chemists, we're interested in the transfer of heat during a chemical reaction. Well, if we think about the chemical reactions that we do, we have very specific conditions that we do our chemical reactions in. So quite often we're in a lab, we've got a beaker, we're doing something magical inside of that beaker, and that beaker is open to the room around it, right? So temperature might change, right? Temperature might increase, decrease based on the chemical reaction. But almost all of our chemical reactions in chemistry, certainly in general chemistry, are at constant pressure. So with these systems being open and to the room around it, the pressure stays the same. It doesn't increase or decrease at all. Because of these very specific conditions we work under and the frequency with which we work under them, we can study heat under these conditions. We can study heat and say, you know what, this is how we study heat when the pressure is constant. So that's really the segue into enthalpy. So enthalpy is just the study of heat when we are at constant pressure. Because we work under constant pressure so much, chemists are like, hey, let's give it a special name and we'll call it enthalpy instead of calling it heat. So they call it enthalpy. So enthalpy is denoted with a capital H, and that's how we'll study it. Okay. Of course, we're going to study the change in enthalpy. Okay. The official definition or the official formula, we will not use this formula. The official formula is what you see on the screen here. So change in enthalpy is the change in energy plus this guy right here. Okay. Well, this guy right here has another name, and that name is called work. So that's how we define work in chemistry. But remember in our chapter, we're ignoring the work piece, right? So here's our connection. Enthalpy is our measure of energy as long as we are at constant pressure. And so as general chemists, we are going to assume that we are at constant pressure. So now when we study energy, it will no longer be called energy. It will no longer be called heat. It is specifically going to be called enthalpy. Okay? So enthalpy is the heat evolved in a reaction at constant pressure. Okay. Chemists use thermochemical equations to represent the matter, so what's going on in the chemical reaction. We can also use these chemical reactions to represent the energy change or the heat change. So this is how you'll see the information depicted. So here we see a chemical reaction. Hydrogen reacts with oxygen to produce water. Next to that, you now see the enthalpy of that reaction written to the side. So delta H is the change in enthalpy, and the change in enthalpy for this given reaction is negative 286 kilojoules. So again, we see that kilojoule as our unit. That's just another way of indicating that this is in fact an energy measurement. Okay? So the enthalpy change indicates the amount of heat associated with this reaction. Whether it's positive or negative tells us which way that heat is transferred. Okay? If the enthalpy change is less than 0, so another way of saying that is it's a negative number, the reaction is what we call exothermic. In this case, heat is exiting the system. So how does heat exit a system? Well, you feel warmth coming off of that reaction, right? So if I were to put my hand next to an exothermic reaction, my hand would start to warm up because there's heat coming off of that reaction. If the change in enthalpy is a greater than 0, and we could call this a positive value, the change in enthalpy is positive, then we call that an endothermic reaction. Heat has to enter into the system. We have to put heat into that process. Okay. So here we see exothermic, here we see endothermic, so those are two of the values. And one of the things I want you guys to connect with these two. Here in the first reaction, we have hydrogen reacts with oxygen to produce water. That's an exothermic reaction. But if we look at the opposite, so we look at water breaks down into hydrogen and oxygen, that is an endothermic reaction. So reactions can happen in the forward direction, we're creating water, or they can happen in the reverse direction, we're breaking down water. And the enthalpy associated with those two will always be opposite. If one is exothermic, the other is endothermic, and vice versa. So here's just driving home that exothermic, endothermic idea. So endothermic, heat is entering into the system, and that would be denoted with a positive value for enthalpy. Here we have an exothermic reaction, heat is exiting the system, and that would be denoted with a negative value. So that's your introduction to enthalpy. What we're going to do with the next series of videos is we're just going to explore enthalpy from a multitude of different ways. So we're going to talk about calculating, we're going to talk about what it means. So we're just going to start to get to know enthalpy by studying it from a bunch of different directions. But that's your introduction to enthalpy. I hope you guys found this helpful.